Hello and welcome to my presentation about Process Bus and its implementation in ZProtect 5. Let me introduce myself. My name is Stefan Flemming. I'm a product lifecycle manager for ZProtect 5 devices and responsible for Process Bus and IEEE 1588 PTP time synchronization. What is a Process Bus? It is the digital interface between the process level and the field level. As shown on the left side of the illustration, traditionally the instrument transformers from the process are directly connected to the IDs of the field level, for example the protection devices. With Process Bus, the idea is to digitize the analog and binary signals via a so-called merging unit. The merging units are usually installed as close as possible to the process level to reduce the amount of copper wiring. Due to the low signal level of LPITs, which are difficult to transmit over long distances, the use of LPIT always requires digitization at the process level via a merging unit. Let's take a closer look at the advantages of using the Process Bus. For the primary equipment, the current transformers drives the current through a much shorter cable to the merging unit. This means that the current transformer with a low burden can be used. Reducing the CT burden in return lowers the cost of the primary CT. Instead of being located with the protection cabinets, the CT connection is moved out to the primary equipment and the risk of open CT circuits is reduced or limited to the primary equipment. The operational safety, which is important, is thus significantly increased. Due to a low signal level when using LPITs, there is inherently no danger of harmful voltages at all. You save costs by reducing copper cables, which leads to faster installation and commissioning, among other things. You increase independence through an interoperable design that enables multi-vendor solutions based on the IEC 61850 standard. Smaller protection devices, cable trays and so on reduce the required space in the control building and shrinks the overall footprint of the substation, and which saves civil and other costs. When protection requirements change and new protection IDs need to be installed, there is no reason anymore to touch the primary equipment. You simply subscribe to the already existing current and voltage streams at the Process Bus. This increases your flexibility and scalability by making it easier to adapt to future requirements and necessary integrations. Let's get into some applications. For example, a central protection using our decentralized busbar protection device 7SS85. You can protect up to 10 feeders, for example with impedance and overcurrent protection, and additionally with the busbar differential protection. Let's take a look at a transformer feeder. You can either use individual merging units for each instrument transformer if the instrument transformers are distributed further in the plant. Or a single merging unit reduces the number of merging units in the field if the instrument transformers are more centralized. In either case, the merging unit is your interface to the primary equipment and collects further data from various sensors. The merging unit connects to the Buchholz relay and pressure relief devices and can cause direct tripping of the transformer circuit breakers. In addition, the merging unit can control the transformer cooling and switching devices and act as a tap changer controller as well as takes care of automatic voltage regulation. In my last application example for today, I want to talk about line protection. As mentioned earlier, the mix of directly connected analog values and values received via Process Bus is possible. This includes also the line differential application. The cool thing about this is that the opposite end does not need a precise time synchronization. Even a ZProtect 4 line differential protection device could be installed and work together with a modern Process Bus installation at the local end of the line. The ZProtect 5 digital twin allows you to individually simulate and test your ZProtect 5 Process Bus client. Testing of protection functions and protection coordination via simulation of subscribed currents and voltages is possible. SCADA communication and goose signals between ZProtect 5 devices can be tested. You should stay tuned. In the future you will be able to simulate a complete ZProtect 5 Process Bus system with this digital twin. This includes the publishing of sampled values by a merging unit and their subscription in the ZProtect 5 protection devices. Let's take a closer look at the merging unit itself as the data concentrator. As a full-fledged member of ZProtect 5, the merging unit 6MU85 is flexible in hardware and can be perfectly tailored fit to your application. You can equip the merging unit with the desired number of binary inputs and outputs, including any high-speed tripping outputs that may be required. The same applies to the current and voltage inputs. The use of redundant power supply is optional possible and increases the availability. As teased before, the merging unit is your interface to various primary equipment, such as current and voltage transformers, switching devices, temperature sensors, tap changer, Buchholz relay, flow sensors, and so on. You can realize, for example, backup protection functions, field and bay interlocking, transformer cooling control, automatic voltage regulation, or any other user-defined logic. Coming to some technical highlights. The 6MU85 merging unit can publish on up to 4 Ethernet interfaces sampled values, which means 2 streams per Ethernet module and in total up to 8 sampled value streams. Each stream can contain up to 32 analog values per single stream, with a flexible allocation of currents and voltages to be published, in accordance with IEC 61869 Part 9 and 13, as well as IEC 61850 Edition 2.0 and Edition 2.1. The synchronization of samples can either be realized with IEEE 1588 Precision Time Protocol and for retrofit scenarios via PPS or IREC-B. The support of IEC 6150 Goose and MMS on the same Ethernet interface is supported as well. What type of streams are supported? The 6MU85 merging unit as well as the ProSpace client are supporting the sampling rates as per IEC 61869-9 and for backwards compatible streams as per 61850-9-2 LE. To be more fault tolerant, the ProSpace client interpolates a single missing sample without jeopardizing protection functionality. Let me explain on the example of a breaker-and-a-half scheme an important advantage using IEC 61869 flexible streams instead of IEC 61850-9-2 LE streams. In a breaker-and-a-half application, you must publish 2 sets of currents and 1 set of voltages, which means 2 9-2 LE streams would be required, emitting in total about 13 MB per second for 4800 Hz sampling frequency and 1 ASDU. Using flexible streams, all analog current and voltage values can be assigned to a single sampled value stream. Using same sampling rate and ASDU count, this single stream emit about 7.7 MB per second, which is a reduction by 41% compared to the 9-2 LE type of streams. Quite similar is the comparison for the higher sampling rate of 15,360 Hz. In conclusion, a consequent use of flexible streams provides a big potential to save Ethernet network bandwidth. For such a system, reliability and security is a must. Besides the rugged designed hardware and by standard conformal coated electronic boards, special care needs to be given to cybersecurity. Cybersecurity is embedded in ZBTech 5 and provides secure communication with TLS, IPsec and client-server authentication, firmware integrity checks, product cert for vulnerability handling, centralized account management and role-based access control, centralized security, event logging, future readiness with PKI support. How about the opposite end, the ProSpace subscriber, the protection devices? Up to 3 Ethernet modules can be used to subscribe 16 streams per module, which is in total 48 streams. For sure, also Goose and MMS is supported on the ProSpace interface as well. I like to highlight that not only most of the protection functionality is supported, also in case of line differential protection, no synchronization on the remote end is required, as shown before in the application example. Interoperability with third-party merging units is given by nature, with the support of IEC 61850 Edition 2.1, which introduces additional settings to regulate the interpretation of a sampled value stream content. Mixing directly connected currents and voltages with sampled values isn't an issue too. Standard functionality as sampled value supervision and the support of test and simulation bit is obvious. One of the highlights is the support of the sync source identity in conjunction with IEEE 1588 PTP. As you see, the protection devices can be fully used also to subscribe to sampled measured values. Let me focus for a bit on one of the highlights. As pointed out on the ProSpace client features, SIPREC 5 uses the sync source identity as it is recommended in IC 6150 edition 2.1 to increase the availability of a ProSpace system. How is this achieved? The 6MU85 protection devices are synchronized by IEEE 1588 PDP. The published streams are containing the Grandmaster identity of a 1588 Grandmaster clock, which synchronized the stream. With the knowledge of the synchronization source, a loss of GPS can be mitigated, because samples do not need to be globally synchronized. It is sufficient that the streams are relative to each other synchronized. The protection device takes this into account and evaluates the synchronization source and keeps the system operational without limitation if all streams are synchronized by the same source. Let us get to the ProSpace network himself. In a ProSpace network, it must be ensured to deliver sampled values bumpless, even in case of a network defect. This can be achieved, for example, with PRP, the Parallel Redundancy Protocol. Siemens recommends loading the network with a maximum of 60% of the network bandwidth to ensure performance and keep capacities for additional network services like Goose or engineering access. To steer the network load, VLAN or MAC filtering shall be used. To save network equipment, also HSR, the High Availability Seamless Redundancy Protocol, could be used as well. Besides to the 60% network load limitation, a maximum of 15 devices in such a ring ensures the precise sample synchronization using IEEE 1588 PDP. With a PRP backbone to the HSR rings, larger network configurations with multiple HSR rings are possible. The connection between the HSR rings and the PRP backbone requires redundancy boxes, also known as redbox. Please make sure that all the used network equipment is IEEE 1588 PDP aware to not jeopardize the accuracy of the sample synchronization. As you just learned, the ProSpace network should not be loaded with more than 60% of the network bandwidth by sampled values. The network load can be segregated into virtual LANs using VLAN or MAC filtering. This allows the use of one single cost-optimized physical network, even if the total load of the sampled values is above the 60% of the individual 100 MB links to the merging units and protection devices. As an alternative solution to handle the network load, physical separated networks could be used. This would reduce the complexity for the network engineering. In the picture, a possible approach of separate networks for field-unique samples, the distribution of the busbar voltages and distribution of the currents for busbar protection is shown. With this, I'm at the end of my presentation and would like to say thanks a lot for your attention.